This is question number 25 on the practice homework 2 for session 3 on the time value of money. So here we are provided with two options, two salary options. One is that you can have $68,000 per year, and that's for the next 2 years. So that's option 1. Um, that's annual salary. And option 2 is that you can have $57,000 per year for the next 2 years, but then you will also have a signing bonus of $13,000. And the bonus is paid immediately, but the salary is paid in equal amounts at the end of each month. So we have a monthly payment, and if the interest rate is 8% compounded monthly, what is the value today of each option? So I think we have mentioned this many times. The interest rate is generally quoted in annual terms. So that's called APR. So in this case, 8% should be understood as the APR. And then I just put option 1, option 2 here. And let me first put all the parameters for each option in Excel sheet. First input is that salary, right? Annual salary. So this is a salary per year, and for option 1, that's going to be $68,000. But then remember here, the salary is paid in each month, so we need to work with the monthly amount. So that basically gives us the payment, right? Payment here is the annuity payment. So basically, option 1 should be understood as a annuity because we have basically each year we have 12 monthly payments, and that continues for 2 years, which means we have 24 equal monthly payments. So each payment should be simply the salary, annual salary divided by the number of months within a year, 12. So that's basically the payment. And then the next information is the interest rate, right? The interest rate, again, this is APR, and that's 8%. But since we are working with monthly payment, so the interest rate should also be monthly interest rate. So monthly interest rate is, let me use R to denote that, and that should be equal to the APR divided by the number of months within a year. And here it's 1%. I believe that's because the format of the cell is I only kept, actually I don't keep any decimal place. So once I change that to be 2, you can see this actually is 0.67%. And then we also need the number of equal payments or number of annuity payment. So that's N. In this case, we have 2 years, and each year has 12 payments. So it's going to be 2 equals 2 times 12. So now with all these inputs, we can calculate the present value of option 1. That equals present value PV open. So the first argument here is rate. That's the monthly interest rate because every number should be quoted in monthly formats. And the second argument here is NPR. So that's the number of annuity payments. So that's 24 here. And the third argument here is payment. So that's this payment. But again, if we want to get a positive present value, we need to put a negative sign in front of this monthly payment. And then we don't have any future value. That stands for the lump sum future cash flow. And here we only have the equal monthly payments. So that's not the future value in this function. So now we can close that, and then that gives us the present value of the first option. So let's continue. The second option, salary per year, is 57,000. So that gives us the payment to be $50,000 divided by 12. And we also have a signing bonus, right? So signing bonus is 13,000. So signing bonus is paid immediately, so this is already present value. But then we need to add the present value of the second option's equally monthly salaries, and then to this signing bonus. That's the total present value of the second option. And then the APR for this, for both, is 8%. Hence, R is also the same as option one. So that's going to be 8% divided by um, divided by 12. So let me put that in percentage format. And then finally, N for the annuity is also the same as option one, because this is for 2 years and we have monthly payment. So now present value of the second option is equals PV, and then the first argument again is the interest rate, which is this monthly interest rate, and NPER is the number of payments, and then the payment is right here. But again, if I want to get a positive present value, I need to add a negative sign in front of this payment. So that basically, so far, if I close that, so far this gives me the present value of that 2 years monthly salaries. But we are not done yet for this option, right? Because we also need to add the signing bonus that's paid right now. So that's already the present value. So once I do that, you can see present value of the second option is this number. So if you compare these two, you can see that actually the first option is more attractive, right? Because the present value of this first option is higher than the present value of the second option. So yeah, even though in this case the second option gives you a signing bonus, but the lower salary, annual salary, does not I mean, the signing bonus does not compensate for the lower annual salary. The loss of the annual salary is more than the gain from this signing bonus. Of course, the loss and gain here should both be quoted in annual or in present value terms. Otherwise, we cannot compare, right? That's the purpose of calculating the present value. So that's basically to put the numbers at the same time spot, so the numbers are comparable. All right, so that's basically what this question.